If weight loss was just about eat less and move more, it would be easy. But the human body is far better at preventing weight loss than it is at preventing weight gain. And that's not a character flaw or a lack of discipline, it's biology. When you try to lose weight, your body responds. Hunger increases, energy expenditure drops, and efficiency improves. And unless you understand that response, every diet will feel like an uphill battle. Today, we're going to unpack what actually happens when you try to lose fat, and why understanding the system changes everything. At the most basic level, body fat represents stored energy. If you consistently take in more energy than you burn, that excess gets stored, largely as triglycerides in adipose tissue or fat cells. If you consistently burn more than you consume, your body must access stored energy to make up the difference. That's a caloric deficit. There is no scenario in which fat loss occurs without one. But here's the part that gets missed. You don't directly control energy expenditure the way that you think you do, and you don't consciously regulate hunger. The body regulates both sides of the equation. Energy intake and energy output are not fixed numbers. They are dynamic biological variables. And when weight starts to drop, those variables change. When you lose weight, several coordinated things happen. Ghrelin rises, leptin levels fall, sometimes dramatically, hunger increases, satiety signals weaken, resting metabolic rate declines. Non-exercise activity thermogenesis, all that unconscious movement you do during the day, subtly decreases as well. You fidget less, you move less, you burn fewer calories doing the same tasks. This is known as adaptive thermogenesis. It refers to the reduction in energy expenditure or metabolic rate that occurs during weight loss, often beyond what would be predicted from changes in body composition alone. In other words, your metabolism becomes more efficient. It's not metabolic damage, it's metabolic adaptation. Your body is trying to conserve energy. And this is why weight loss often slows even when you feel like you're doing everything right. The system is adjusting. The important point is this. Weight loss triggers a coordinated biological defense response, not because your body is trying to sabotage you, but because it interprets weight loss as a potential threat. Why does the body respond this way, though? To understand that, we need to understand our history. For most of human history, food availability was inconsistent. There were periods of abundance, as well as long periods of scarcity. Body fat wasn't about aesthetic. It was insurance. It provided stored energy during famine. It supported immune function. It signaled reproductive readiness. It increased survival during illness. From an evolutionary standpoint, losing body fat unintentionally could mean danger. So the human body evolved to defend against weight loss far more aggressively than weight gain. Starvation killed people. Gaining a few extra pounds in October? Well, that was the whole point. There was little evolutionary pressure to prevent weight gain in times of abundance, because abundance rarely lasted. Today, that same system operates in an environment of constant food availability. You're running ancient survival software in a modern metabolic environment. And that mismatch is central to understanding weight regain. So, what is fat loss biologically? Body fat is stored as triglycerides. Each triglyceride molecule has 3 fatty acids attached to a glycerol. When you're in an energy deficit, insulin levels fall across the day. Lower insulin exposure allows fat cells to release stored fatty acids, a process called lipolysis. Those fatty acids enter circulation and are oxidized by tissues for energy. That's fat loss. It's not about one meal or one macronutrient. And it's definitely not about whatever $60 detox tea your favorite influencer is pushing this week. Fat gain and fat loss reflect the cumulative balance of energy over time. Insulin plays a role as well, because it is anti-lipolytic, meaning it prevents fat cells from releasing fat. But chronic energy surplus is the primary driver of fat storage. Carbohydrates are not uniquely fattening. Fat is not uniquely fattening. Chronic caloric surplus is fattening. And chronic deficit drives fat mobilization. But, and this is critical, the more aggressive the deficit, the stronger the biological pushback tends to be. Most diets fail not because people are weak. They fail because aggressive restriction amplifies the biological defense response. Hunger increases, metabolism decreases, food becomes more rewarding, environmental cues become harder to ignore. If the deficit is too large, the system pushes back harder. Add in all or nothing thinking, unrealistic expectations, and an environment filled with hyper-palatable food, and relapse becomes likely sooner or later. Biology usually wins against restriction alone. So, if aggressive restriction amplifies the biological defense response, then what actually works? Check out the next video to find out. I'm the Science MD, and this is the science behind your health. Thanks for joining, and see you next time.